How's it going, everybody? My name is Nick Auerbach,
My name is Joseph Wojciechowski.
and this is our 287 final project video. I'm going to share my screen. Cool. So our project is called Exploring Burlington Police Department Incident Reports Through the Lens of Race and Ethnicity. So we're going to start with our motivation, our problem statement, and then some related work that kind of inspired us and inspired some of the methods that we used. So as you all know, systemic racism and kind of the Black Lives Matter movement have been in the spotlight of conversation for the past many years, and especially the past 6 to 8 months, kind of ignited by the Breonna Taylor and George Floyd incidents and so many more incidents. The Battery Park movement in Burlington was kind of our manifestation of that, and something that we wanted to explore is applying these data science methods and the data science lifecycle to data that was accessible to us, to show that while Vermont is kind of known as a very liberal place with regard to systemic racism, it's really not different from anywhere else.
So the way we went about that is we grabbed data sets that were available on the Burlington Police Department website. And they were on things like incident and arrest and use of force. And our plan was to merge them all together and then to analyze them to try to find patterns and like discrepancies between the BIPOC community and the white community.
Cool. And something that we wanted to mention is that there's some inherent bias associated with using data from the Burlington Police Department. And there's also some like Burlington's 83% white, so there's going to be some disproportionality in terms of the demographics of the population that are going to make modeling kind of difficult.
Very true. So one of the past works is over the summer, the city released a report doing analysis on their arrest data and comparing the Black populations and white populations, and they found interesting things like that Black populations had more severe charges, while less severe charges were in like a higher percentage for white individuals. And they also encouraged people to do further analysis, which is something that got us interested in doing some further analysis.
And a couple of the other links down there also address the issue of police data collection bias. For the scope of this project, we couldn't really implement any of that, but it was just something to maintain an awareness of. So now we're going to talk about some of the cleaning and exploratory data analysis.
Yeah, so cleaning the data and merging it ended up taking quite a large amount of time. We were combining 5 different data sets, and while we were combining them based on one column, there were a lot of columns they shared, and it was difficult finding ways to combine the values in the columns without overlapping them, and then also just data was recorded differently in a lot of the columns. So things like charges would differ from column to column, and race would be recorded differently. So finding a way to combine all of that was very difficult.
So we kind of wanted to perform our EDA with classification in mind. We created this BIPOC Boolean value, and we wanted to classify a bunch of different features using that. And so, initially we wanted to use our EDA to kind of minimize the number of features in our data set because there are hundreds and hundreds. We did end up modeling with, almost 60 features. So kind of in a way we failed, but we did learn a good bit about the data throughout our EDA process. On the left, we have just a plot showing quantity of incidents between white and BIPOC. and the proportions are very similar to that of the city of Burlington. So that was interesting to us. And then on the right, we just have a collection of incident call types like assault, domestic violence, drugs, property crimes, which we weren't totally sure about as there wasn't a code book for that specific feature. But it's interesting to see how maybe assault could show some interesting associations with race in the future, as well as drugs and domestic violence. And then here we have number of officers involved in an incident and the type of call level, which is really just the subjective severity of an incident that a police officer selected when creating this report. And because there could be some implicit biases involved in these two features, we decided to plot them. An officer might be more likely to recruit backup in a situation in which there are Black people, or an officer might be more likely to categorize a situation as more severe if a person is Black due to these implicit biases.
Yeah, so here we have two maps. One of them shows white incidents, and one of them shows BIPOC incidents over Burlington. And at first glance, the patterns of where the incidents are look pretty similar. They're kind of centered around downtown. But then you can notice a few patterns, like in the north end, like kind of along North Ave, there is a much larger frequency of white incidents than BIPOC incidents. And the same goes for the UVM area, where there's a very strong cluster of white incidents, but there's only a few BIPOC incidents in that same spot.
So let's get into kind of the second big chunk of the data science lifecycle.
Yeah, so one of the big chunks was fitting our data into the models, and two of the models that we found were really helpful were random forest classifiers and linear SVC model. The reason we went with random forest classifier is that it pretty accurately trained the data, and it also gave us a pretty good area under the receiving operator characteristic curve, which just kind of showed us how well it was predicting outcomes. And one of the large reasons we went with linear SVC was because even though it wasn't training the data as accurately, it was really easy for us to interpret and for us to see which columns and categories the model found important to predicting like BIPOC or not for incidents.
So this visualization is similar to that of assignment 6 in that it shows the top 10 most associated or least associated with race. And it should be noted that a couple of these features are a little bit wonky. We didn't drop them, but for example, that top feature only has 2 true Boolean values out of thousands and thousands. So we decided to select a couple of these features that we knew didn't have a ton of missing values, etc., and plot those from this plot. So here, Yos was going to talk about some of those kind of interesting features.
Yeah, so one of the features we found interesting was misdemeanor charges, and one of these shows misdemeanor charges for BIPOC incidents, and the other one for misdemeanor charges for white incidents. And it's pretty noticeable that there is a higher amount of misdemeanor charges for white individuals than for BIPOC individuals.
And here we have a plot that we actually showed before. It was kind of one of the first plots we made in our EDA stage, but we just wanted to revisit it because assault and domestic violence charges were so associated based on that linear SVC. And here we see that this is true. The model was trained well according to this data, and it seems that in all assault incidents and domestic violence incidents, it is more likely to involve a BIPOC.
Yeah, and then another category we found interesting was felony charges. So here is a map of that by race, and you can see there's like more BIPOC felony charges than the usual 20% that you would expect. It's kind of a more even ratio than that. And then the same is also for drug charges in the other map, where you can see there is kind of a higher ratio than you would expect in a more even ratio between white and BIPOC individuals for that charge.
So to conclude our presentation, kind of to put it bluntly, all of these look cool, but we're skeptical of them. And the reason we're skeptical is because there are some interesting most associated features that we got from these visualizations and some of the models. But because of the bias inherent to the data collection and the characteristics of the population, we want to call into question these associations. And it's kind of one of those situations where we say we know the systemic racism is there, but this specific data science lifecycle doesn't prove it. So while our results are intriguing, there isn't really a concrete conclusion. There's kind of a null conclusion going back to our problem statement, trying to find trends between BIPOC and white people. And so to wrap things up, something that we wanted to say was, while this data set is really interesting, and it's a very kind of technical data set from a police department, the intersectionality of racism cannot be ignored. There are implicit biases, financial inequities, educational disparities, and so many other kind of aspects of our lives that white people benefit from and might lead to some systemic racism. And the data set that we worked with might not show this. And then also modeling with the data set is difficult because it's pretty small, relatively speaking, and the population proportions are pretty skewed. 83% white in Burlington, as I said. And, you know, there are some strategies that we explored, but eventually didn't implement, like extracting a subset of the data with equal proportions of BIPOC and white people, or just kind of directly comparing our models with the actual population proportions. But there's a lot more that we could have done. And then finally, we explored a lot of the nuance of the BIPOC community itself. We created this Boolean feature to make classification really concrete. But there are so many different ethnicities within that community and so many different ways that people identify. And so we felt like this is a highly incomplete and this report lacks a lot of nuance.
Yep.
That's all we got. Thanks for listening.
Thank you.